Chapter 6, I'm going to talk about gases. This is a quote from James Maxwell, who lived in the 1800s. So many of the properties of matter, especially when in the gaseous form, can be deduced from the hypothesis that their minute parts are in rapid motion, the velocity increasing with the temperature, that the precise nature of this motion becomes a subject of rational curiosity. So this section 6.1 in the newer versions is titled Supersonic Skydiving and the Risk of Decompression. So that's what it says at the bottom there. I'm not going to talk about either one of those because in previous versions he talked about breathing, and I think that's maybe a little more relevant to most of us. So if you're curious about that, yes, these don't match.
Mommy's reading and I'm like, that's not breathing.
Yeah. I mean, do you ever just stop and think about breathing?
Sometimes. I'm just sitting back here really breathing.
Yeah. You know, it's funny because there's so many things in life that we just see and do every day and we don't actually stop and think about them. And then if you stop and think about any of them, they start to become really strange, right? So breathing, how does that work, right? This is an interesting factoid. Every day you move about 8,500 liters, 25 pounds of air in and out of your lungs. It's breathing. Breathing is possible because your body can create pressure differences. So let's talk for a minute about what pressure is. So pressure can be defined as a force divided by an area. So a force divided by area, for gas molecules are going to hit a surface, and when they hit, they exert a force, and it's spread out over an area. For a gas molecule, that's a very, very small area. Here we have a picture of gas molecules, and as they strike a surface, they exert a force. They exert a pressure on the surface. So the pressure that a gas exerts depends on several factors. How many gas particles there are in the container, which we could think of that as the concentration, how many particles in a given volume. More particles, more hits, more pressure. It'll depend on the volume of the container and the average speed of the gas particles. So when you inhale, you make your lungs larger. Increasing the volume causes a decrease in the gas concentration in your lungs. That's a lower pressure. The external pressure, atmospheric pressure, is constant, and so the pressure in your lungs becomes lower, and that causes air to move into your lungs. We call that taking a breath. Everybody try it. It's good. It's good. So what happens then when you exhale? You make your lungs smaller, which increases the pressure and pushes the air out. I know, this is really mind-shattering stuff, right? We got to start slow first thing in the morning.